So hello friends, today's topic is image processing hands-on demo using QGIS. My name is Prasun Kumar Gupta. I am a faculty with the Geoinformatics department here at Indian Institute of Remote Sensing, Dehradun. And today I will show you how to do some basic image processing on satellite imagery using free and open source software QGIS. The handout for today's session, that is the step-by-step instructions on how to do this session, is available on this link, bit.ly/QGIS hyphen or dash image dash classification. So you can just write or type this link on your web browser and it should download a PDF file which has instructions of today's session step by step. Although I will be showing you some data for the Dehradun city, you can perform the same exercise for your own city by downloading data from ISRO's Geo portal. This is called Bhuvan. This is the link of the website bhuvan.nrsc.gov.in. You open your browser, paste the link, and here you will find a option called Open Data Archive. Click on Open Data Archive. Select resource at 1 slash resource at 2 list 3 and search for your city. Let's say you are working in Pune. Search for your city in the search bar here on the top left. Uh, or you can simply use your mouse controls to zoom in or zoom out using the scroll button. So let's go to here Mumbai and select a tile. So you click on tiles, start, select the tile, then stop, and then now it is giving me. Okay, now I click on next. You will see what are the uh, images available. So you will see that image for October 2008, November 2011, so on till as close as 3 years back, May 2019. Images are available. You can click on view to see a small thumbnail of the image. Then you can click on this download button to download. For this, you will need to create a small account. You can click on login here. If you are not a registered user, you can register just like an email ID. Click on new user, enter the details, and you can download the data. Once you download, you will get a zip file. Inside the zip file, there will be 4 bands, namely band 2, band 3, band 4, and band 5. Okay? Since list 3 does not have the blue band, so band 2 refers to the green band, band 3 refers to the red band, band 4 refers to the near infrared or NIR band, and band 5 refers to the SWIR or the short wave infrared band. So we will be using these 4 bands for today's exercise. Okay, I am also trying to install the latest version of QGIS in parallel. This may take just a few minutes. In the meantime, let me tell you about the software that we are going to use today. Here I have opened the browser and I have searched for the term QGIS in a search engine. The first result shows welcome to the QGIS project. So what is QGIS? It is a free and open source cross-platform desktop geographic information system application that supports viewing, editing, printing, and analysis of geospatial data. First thing is, it is free and open source. So, free, that means you don't have to pay any money to download and use the software. It is open source, that means the source code is available. If you are a programmer, if you know C++ or Python, you can change the source code and improve or create your own customized versions of GIS software. It is cross platform, that means it not only runs on Windows, it also runs on Linux and Mac. It's a desktop based GIS software, so primarily it is used on a desktop, but there are some versions which run on a server as well as mobile devices. Although it is a GIS system application, it also has good capability of image processing also. So if you go to the website, you will see that there is this is a website of QGIS. Okay, I have my installation is complete. Let me just start QGIS so that we can save some time. So this is the website of QGIS. As soon as you scroll down, you will see there is a download now button. You click on that, you will see there are a lot of options, something called network installer, standalone installer. Then within standalone, there are two options: latest release and long term release. So if you are installing for the first time, I would suggest you take the latest package, which is richest on features. If you are working for some project which you think would last for 1 or more years, and you don't want the latest features, you want the most stable version, you can take this. But in any case, both of them work fine. The latest version has some new features which are all experimental in nature. Then you have different instructions for installing on a MacBook or on a Linux based platform or mobile apps and so on. Okay, so once you download it, once you click on this, it will download a file which is roughly, so I have downloaded it here. It says it is roughly about 1 GB. And once you install it in Windows, you can see that it creates a folder called QGIS 3.2.26.2, which is the current version as of September 2022. And there you will see that the QGIS desktop software is installed. This is the software that we are going to use. Very interestingly, you will see some other names like Grass GIS and Saga GIS. These are different other softwares. But QGIS is a very popular software, and nowadays it inculcates or adds the power of Grass as well as Saga in QGIS directly. So QGIS also has the power of Grass as well as Saga. So once QGIS is installed and you start it, this is the interface that you will see. Let me talk about the interface before we start adding data and processing it. You see the first thing that comes up. Let me click on new project and make it a little bit more cleaner. Let me add some panels that I will be using, namely the layer styling panel and the processing. I go to view panels and processing toolbox. So these are the two things that I have added on the right side panel. On the left side panel, you see there are two panels. One is the browser. Just a second. So On the right side, there is the browser panel, and this is called the layers panel. This is where the layers will be listed. This is called the map view. This is where your map will be viewed. On the right side, there are two panels. This is called the processing toolbox, and this is the layer styling toolbox. Currently doesn't show anything because no layers have been added. On the top, you have the menu bar, project, edit, view, layer, settings. We'll be using some of them. Then there are shortcut icons for a new project, open a project, save project. Some navigation tools like zoom in, zoom out. Then some important things like identify features, measure something. Then how to add a layer, create a new layer, and so on. So, without further ado, let us start adding some data to the software. How do we add data? In GIS, everything is a layer. So, you would have to add a layer. You need to click on layer, add raster layer. As soon as you click on it, you will see a new box which comes up. This box is called the data source manager box. This manager box is a single place from where you can add vector, raster, even mesh, point cloud, uh, text from your Excel sheets. They are called delimited text, or even from your GPS device, or connect to some database like Spatialite, Postgres, Oracle, or even download data from the web using WMS, WFS, and so on. So right now we are interested in adding some raster data. So let's click on raster, browse. I go to today's folder and I select list 3 Dehradun, 5th April 2019 band2.tif file. I click on open, then click on add and close. Wow, we see something. What is this? This is the second band. Now, do you remember what band 2, which part of the electromagnetic spectrum is band 2 from? Is from the green portion. Okay, band 1 is the blue portion, which is not there in the list 3 sensor. That is why the numbering starts from band 2. So what do we see? This part is the Dehradun city, and then the Mussoorie town here, and other hills to the right. Uh, what else we see? We see that it says the layer's name and it shows me the minimum and the maximum value in the layers panel. Now, right side, the layer styling panel was showing empty. Now it has a lot of values. It says it has been stretched to min max, and the min and max has been set to 46 and 238. And it is in single band gray symbology. There are different other symbologies also. And then there are other options. Okay. So we can use the navigation tools like zoom in. So let me zoom in here to the Dehradun city. You are seeing features which have high reflectance in the green part as bright and low reflectance in the green part as dark. Okay, so one very unique feature that you're seeing on the western side, a circular white. This is a cricket stadium, also called the Rajiv Gandhi Cricket Stadium. And in GIS, you can click on the I button, the identify feature button, to click on individual pixel values and have a look at the values. So if I click on the dark pixel, it says the pixel value is 92. If I click on the bright pixel, it says the pixel value is 234. Right? So brighter values are shown with higher, whiter values, or brighter values are shown with are basically higher value. Uh, Not only that, you can use the tools like measure to roughly measure what is the perimeter of the stadium. If you want to have a run around the stadium, you would be covering roughly 700 meters uh, on the ground, 659. So, a very easy way to add data, look at the pixel values, measure certain features, and so on. Uh, you would be like, why is this so coarse? Because this is from the list 3 sensor. Now, let us have a look at the properties or the metadata of the file, which is very important. You need to right click on the name of the layer on the left side and click on properties. You will see that a new box comes up, and in this box I need you to click on this information tab. Here you see a lot of good information is given. First is the name of the layer, second the path. Many times several layers get added to the layer panel and you lose track which file is kept where. So you simply go to the properties and look at the path, where the path is kept. If you click on it, it will automatically open and highlight the file that you have selected the properties. It gives the size, when what was it last modified, the extent, that is the top left corner and the bottom right corner of the image, the number of pixels, rows, the number of columns is given as width and height. The data type, it says uint16, that means unsigned integer 16. It is a geotiff file, and other metadata information like what is the maximum value, minimum value, mean value, standard deviation are also given. Uh, the coordinate reference system, it says it is EPSG 4326. That means it is a geographic lat long coordinates and it is in the WGS 84 datum. Okay, so all this information is there in the properties tab, which you can explore. Now, first thing that I want to do is I want to show you how to construct a FCC, which stands for false color composite. So basically you need 3 bands. So I have already added band 2 here. I need band 3 and 4 also to be added. So let us go back to layer, add raster layer. Click on this browse button here. Press Ctrl on your keyboard, then press band 3 and click on band 4. Now both the bands are simultaneously selected. Click on open, add and close. Now you will see that on your QGIS layers panel, you have band 4 and band 3, all the 3 bands added. Now I will use a function called the merge function to layer stack. The operation is called in other softwares stacking the images. So we are going to do the image stack. How do we do it? We go to raster miscellaneous merge. The name of the function is merge. Click on it, and first thing it asks is what are the layers that you want to merge? Input layers. So you click on this browse button. You say select all. I want to merge all the 3 bands, but there is a catch. I want to arrange the band such that the first band will be my NIR band, the second will be the red, and third will be the green. So I simply need to drag and drop them such that the order becomes 4, 3, 2. Currently it is the reverse. So let me just drag the bands and change the order. Now the order says band 4, band 3, band 2. This is the order that I want, so as to create a false color composite in which uh, the data is arranged. A very important option is this one. Do not forget to put a check in this box which says place each input file into a separate band. If you do not check this option, the process will not get completed. So you must put a check in this box, place each input file in a separate band. The output data type will be same as the input data type. So we saw the input data type was unsigned integer 16, uint 16. So I'll keep the output as same as input, and I can save the output to a temporary file. If I don't change anything, or I could create a new file. So save to file, I say this is an FCC, or let me write completely false color composite. Okay, so it will create a new file called the false color composite. Now let me run this. It may take a few seconds and we are done. It says algorithm merge finished. Now close this box and you see your false color image has been immediately added to the layers panel. Let me turn off the rest of the bands. Here I see my false color composite. You see beautifully all the urban areas, the built up areas, they appear in this color cyan. You see this typical structure to the west, a T-shaped institute. This is the Forest Research Institute, and then you can see these vegetation areas in red, and then as you go up towards the hills, you see this is the Masuri settlement here, and then hills with vegetation on them, and so on. And then you see a river towards the right. The river bed looks very similar to this settlement because similar materials. And here, the stadium that we were seeing, the center of the stadium is red. That means it has a green patch inside. So all this information becomes immediately very visible. This is a very beautiful image which can be used for many such purposes. Okay, next thing is we want to enhance the image. Okay, so let's go back to band number 2. Let's go back to band number 2. I have just turned off all of the images. Now in QGIS there are options to, like, I don't want to view the legends, so I can click on this button which says collapse all, and it will collapse all of the legends. Or I want to see all the legends, then I can expand all and it will show all the legends, which I don't want currently. You want to at a single go show all layers or hide all layers, that is also possible. So let me hide all the layers and only turn on the band 2. Okay, highlight the band 2, and now let us focus at the layer styling panel. So earlier we had opened identify results by clicking on this I button. That is not of use now, so I will close this by clicking on the cross, and let's focus on this layer styling panel. So currently what is happening, the band 2 says the range of values are from 46 to 238. Let us look at, before we go into image enhancement, we need to first look at the histogram of the image. The histogram is a very important graph by looking at which you can understand several properties of an image. So how do we construct a histogram in QGIS? In the layer styling panel, you see here there are several buttons in the vertical fashion. First button says symbology, second button says transparency, the third one says histogram. Now let's click on histogram. You see an empty graph comes up. Right below it, it says compute histogram. Let me click on it, and there you go. I have the histogram of band number 2 displayed on the right side panel. As you can see, on the x-axis is pixel value, on the y-axis is frequency, or the count of pixels which have this pixel value. So you see very few pixels till, let's say, 60 and very few pixels after, let's say, 120. So if we can focus our image between these pixel values, let's say 20 and 120, we should be able to see more information. So let's go back to our uh, first tab, that is symbology, and manually change these min and max options. So let's change min to 20 and max to 120. You immediately see that the image has become very bright, a lot of information. Although in the hills, a lot of things are clear now, but in the plains, a lot of things are getting oversaturated. So we will leave the computer to decide the minimum and maximum limits. Uh, what we need to do is we need to go back to symbology, click on this min max value settings, and click on cumulative count cut. So what does it do? Uh, it does a linear stretch here. Only the pixel values in the 2% to 98% interval will be used as input. The pixel values below the 2% boundary and above the 98% boundary will not be taken into account. So as soon as I click on this, you see automatically it has calculated the upper and lower limits. Lower is now 63, upper is 148. And now you see from the earlier case where it was looking very dull and the information was not very clear, if I select cumulative cut, it becomes brighter and the contrast is enhanced also, and lot of more information visible. So this is the utility of image enhancement. You can enhance the image such that more information is visible. Now let us have a look at the modified histogram. So you see values less than 63 have been removed or have been whitened out, blackened out, and values more than 148 have been whitened out. So I want to see the enhanced histogram. So what I have to do is I have to click on in the histogram tab. I have to click on preferences/actions and select zoom to min max. Also, many people prefer to see histogram as bar chart, not as a line chart. So we will remove this option, draw as lines. Okay. Now let's go back to symbology. Let's go to min max. Let's have a look at the histogram. It looks like this. Let me take a screenshot of this. So, uh, so we will be able to compare it uh, before and after stretch. So this is before stretch. Now let me use cumulative cut to stretch the image. Immediately you see the image gets enhanced. Now if I go to histogram, you see the histogram has changed. Now can you see and compare the change in the histogram? Before the values were stretching from 0 to 200 odd. Now the values are only stretching from 60 odd to 145 plus or less than, let's say, 150. 63 to 148, like that. So the values get stretched, the image gets enhanced. So this is what I wanted to show with respect to linear stretching. Similarly, other types of stretching can also be performed. Now let us go to spatial enhancement. This is what we have done now is with regard to the histogram, the stretch of the pixel values. Now if I want to modify the pixel value based on the pixel values of the neighboring pixels. Okay, so these are also called spatial filters or spatial frequency filters. They emphasize or suppress image data of various spatial frequencies. So what do we mean by spatial frequency? Spatial frequency refers to the roughness of the variations in DN values. Now, if the DN values are gradually changing or not changing at all, that is called a low frequency image. If the pixel values are changing rapidly, first you see high value, next pixel again low value, again next pixel is a high value. So if the spatial frequency is changing, that is called a high frequency image. Okay. So uh, generally you have some noisy data. You may have heard that the satellite data has some noise. So it may have some speckles or some noise. So there may be certain pixels which are very bright. So how do we remove such data? So we use a low pass filter or a smoothing filter. Okay. So let us apply a smoothing filter to the current image which is displayed band number 2 and see what the output, how the output differs. So now we are going to run a low pass or smoothing filter. Generally it will come with a kernel which is a 3 by 3 or a 5 by 5 or 7 by 7 uh, uh, array, and then we multiply that array with each of the pixels, each of the locations, sum the total and assign it to the center value. So that operation is called convolution, and let us perform this. So to do that operation in QGIS, as I told you, GRASS and Saga functionalities have also been included. So let's go and explore the Saga tools. If I go to the processing toolbox, now if you do not see the processing toolbox in your interface, you need to click on View, Panels, and ensure that the processing toolbox is enabled. If you are not seeing processing toolbox also here, it could be that it has got disabled in the plugins. So you click on plugins, manage and install plugins, and click on the installed plugins. You should see a plugin called processing is installed, and this checkbox should be there. This checkbox should be checked. Okay. So you don't need to install it. You don't need internet for this. It is already there in the core QGIS. Just sometimes during installation, uh, in some older Windows operating systems, I have seen that it gets disabled so as to preserve certain properties. So once you see the processing toolbox, scroll down, go to Saga, expand Saga, then scroll down further, go to image, go to expand Saga raster filters. Okay, you need to scroll down further. There is raster. There are many functions like features, images, import, export, projection. Then comes raster, simulations, terrain analysis, spatial and geostatistics, tool chain, so many functions. So you need to go to raster and then filter, expand this, and then use the function simple filter. We are going to use this Saga function simple filter. I double click on it. It gives a warning that some algorithms may encounter issues. I have not seen any algorithm, although I have not run all of them, but the ones which you are going to run today will not encounter any issues. Ensure that the first drop down grid, in Saga they call the rasters as grid. So ensure that grid is set to band 2. Ensure that the filter is set to smooth. Kernel type can be kept to circle. This radius we will change from 2 to 3. Now why did I do that? So the bigger the kernel size, more is the smoothing effect. If radius is 1, that means the kernel size is 3 by 3. If the radius is 2, then the kernel is 5 by 5. If the radius is 3, then it is a 7 by 7 kernel. So I'm taking a larger kernel to show you what is the impact of smoothing. Let me save this as a file called smoothened. Now, by default, Saga files are stored in a file format called SDAT. Uh, let's see if I can change that to .tiff. Let's click on run. Okay, it says TIFF files are not supported as algorithm for the output for the algorithm. Fine, no problem. I will save it as a SDAT file. Now, you would be asking, now this file which is created as that, now I cannot import into different other softwares. In QGIS, I'll show you how you can save the same thing again to GeoTIFF. Okay, so you can do a format conversion after this operation. So let me click on run. What it does, it will do several things. First thing it does is, since Saga works only on grids, S grids and SDATs, it will convert those existing TIFFs, the band 2 TIFF to S grid, then perform the convolution and then give you the output. So here it says that the algorithm simple filter is finished and the result smoothened.sdat has been created. So you see a new file called smoothened has been added. And if I simply toggle this, you see there is a large difference between the two files. Let me use the same stretch options. So right click on the original style, copy style, and right click on the new one, smoothened, click on style and paste. Now if I toggle the two images, immediately you will see the difference. It looks as if you're wearing spectacles of the wrong number. The image becomes blurred immediately, right? That is the concept of a smoothing filter. I want the image to get blurred so as to remove the high frequency details. I want to, I have what I have done, I have run a smoothing filter. A smoothing filter is a low pass filter. It passes the information of low spatial frequencies. All the high spatial frequency, all the rapidly changing values have been truncated or have been smoothened out. Okay, so you see this how uh, these rapidly changing values have been blurred or smoothened out. Okay, this, why would we use this? Why would we do that? This is a typical operation that is performed to correct for noisy data, also called salt and pepper noise. Okay, so when you do these operations, you will understand the utility, but QGIS has the capability of running several types of filters. You may have heard of Gaussian filter, Laplacian filter, majority or minority filter, morphological filters. All these are there in this options. Since the time is short, I'll not be doing, but you can simply again run the simple filter from smoothing, change to sharpening, and rerun this again. And you compare what is the difference between the original, the smoothened, and the sharpened. You will be able to appreciate the meaning of low pass and high pass. Next, let me go to creating band ratios. Now, band ratioing is a very important thing in digital image processing. Basically, you want to minimize the effect of differences in illumination. Okay, so let's say you are looking into a valley and the sun is at a specific angle. The two slopes do not get the same amount of light. So the reflection from the two slopes are also different. But if the two slopes have the same phenomena, let's say both have forest, the ratio of the energy which is reflected is the same. So if x is the amount coming on the uh, slope which is not getting direct light, and 10x is the amount which is coming on the slope which is having direct light, the reflection will be in that proportion. So if the reflection is, let's say, half, the reflection from the dark slope will be x by 2. From the bright slope, it will be 5x because it was getting 10x energy. So to minimize this difference in illumination, we create band ratios. So if I can normally used to enhance certain things like vegetation or soil or certain types of diseases and many things it is used for, or certain geological features. Some uh, some minerals or some certain rock types, they reflect higher in certain bands and don't reflect so much in other bands. So we generally ratio them to create or emphasize this information. So let me directly show you how to create a NDVI, although the handout also has how to create a RVI, ratio vegetation index. But let's directly go to NDVI. For this, we will use the raster calculator. You click on raster, then you click on raster calculator, and you will require the two bands. Which ones? NIR and red. NIR is band number 3. Sorry, where is this? NIR is band number 4 and red is band number 3. Okay, so which is 4 minus 3. The equation goes like this: NDVI minus red divided by NDVI plus red. So NDVI is, what am I saying? Sorry. NIR minus red, please, I apologize. NIR minus red divided by NIR plus red will give you the NDVI. Now NIR is band 4 and red is band 3. So 4 minus 3 divided by 4 plus 3. So you can use the brackets given here, or you can simply type from your keyboard open bracket band 4, double click, then click here, press minus band 3, close brackets, divided by open brackets band 4 plus band 3, close the brackets, and let us save it as NDVI. NDVI dot diff. Yeah, just keep the rest of the options as it is. Click on OK, and there you go. Your NDVI is ready. Generally, NDVI is shown from in different shades so as to emphasize the high values as green. So we go back, click on NDVI, go to layer styling, and instead of single band, you can say single band pseudo color. Okay, and now you say I want a green color ramp, greens. So you see it shows a green color ramp. The darker the green, the higher the vegetation. Or you could use something like spectral. So you see here all the not so vegetated areas are red, and all the medium vegetation is yellowish, and the dark dense vegetation is shown in uh, green. So this is how we create band ratios. Let us quickly do the last part, which is principal component analysis. Now, this is although so what is principal component analysis? It is applied to reduce or remove the redundant data, reduce the file size, only emphasize the important bands. This is also nowadays in machine learning and all becoming very popular. This is a data dimensionality reduction technique, and that can also be performed in QGIS using the functionality available in grass, which is again a third party application. So let me remove the files which we have created, false color and smoothened and NDVI. I only want band number 2, 3, 4, and 5 also. I need band number 5. So let me add band number 5. Now I have 5 bands here. I want to find out how these bands are linked to each other. How much percentage one band can explain the other. So for that, we have to run what is called the covariance correlation matrix. We have to calculate the covariance correlation matrix. Where is that? It is available under GRASS tools. So we have to collapse Saga, open GRASS, then go to raster, and inside raster there should be a function called r dot covar, covar. Let's double click on this. First thing it asks, what are the input layers? I say all of them. Remember, all of them here I mean band 2, 3, 4, and 5. In case you have not removed the rest, don't select them like smoothened, NDVI, and uh, FCC. We don't need those. I only need to select my bands 2, 3, 4, and 5. Okay. And then it says you want to print the correlation matrix. I say okay. It will generate a covariance report. Fine. Let's run this. So what it is doing with each band with another band, it is calculating the correlation. So 4 by we have 4 bands, so 4 by 4 matrix will be generated. It says the algorithm has finished and HTML output has been generated. Open the results dialog box to check it. So you see, by default, the results viewer has opened here. It says a covariance report has been generated. You click on this HTML file and it will ask you which browser do I open it. I say Chrome, and here you go. So what do you have here? Here you have a variance covariance matrix. What does it show? First band with itself is completely correlated. The correlation value is 1. That means band 1 and band 1 are correlated 100%. Now band 1 with band 2, there is 97% correlation. That means the information that you get from band 1, about 97% you also getting from band 2. So they are highly correlated. Whereas band 1 with band 3 is only 50% correlation. So band 3 gives you more information, newer information. Okay. So this is how we interpret this. Now, using this information, or after looking at this information, the next step is to generate the PCA. What does PCA do? It collects all the information and tries to put in minimum number of bands. Okay. So for that, the function is again in grass, but not now in rasters, but in this called imagery. Imagery I.pca. Okay, there are other functions like pan sharpening and functions specific to Landsat, MODIS, and emissivity, and so many other functions are built in. Okay, so I want to run this principal component analysis I.pca. Run it. It says name 2 or more input raster images. Okay, so let's select all the 4 bands 2, 3, 4, and 5. Just keep the remaining information as it is. Let's give an output directory. Let's call it PCA outputs. This was giving some problems in earlier versions. Let's see if it works here. Okay, it has worked. It says IPCA has finished and the output is in the PC outputs folder. Now let's go to the PC outputs folder. You see there is nothing there because yeah, uh, there is some issue with giving your own folder. Instead, let's say we say save to temporary folder. Let it itself generate the folders and let it give the outputs. Let's say run. So as I told you, in the earlier versions, this problem was there. The problem persists. It says now the algorithm is finished. It is in the temporary folder. What is the name of the temporary folder? Just go a little up. You will see that the output is put in this folder in your temporary processing output. You will see our JIDAL complete this file TIFF is created. So just copy the name of this folder, go to your start run, paste the name of the folder and click on OK. You will see a folder with 4 TIFF files, 1, 2, 3 and 4, and the first TIFF file, the one which has the maximum information. Let me add this, drag and drop to QGIS, and you will see that this is the band. This is the new band which has the maximum information. Band number 1 has the maximum information. Then comes band 2, then 3, and finally band 4 has the least amount of information. So before we wind up, the last thing that I want to tell you about is unsupervised classification. It is, although there are tools to perform supervised classification nowadays, even there are some plugins which are allowing you to do machine learning based classification inside QGIS. Due to shortage of time, let me just give you a flavor of how unsupervised classification is done in QGIS. I am removing this last PC output so that only the original 4 bands 2, 3, 4 and 5 are retained. The remaining have been removed. What is the output of classification? It is used to create a land use land cover map of the area uh, where each pixel is given a specific class value. What is this class? It could be forest, it could be water, agriculture, built up, and so on, depending on what level of classification you are doing, and so on. So, broadly, there are 2 types of image classifications, supervised and unsupervised. In supervised, you don't need to give any training data or you don't need to give any samples as input. You just need to specify the algorithm and the number of output classes. Whereas in supervised classification, you need to specify the algorithm plus you have to give some input training data. That means some pure pixels. So you have to identify pure areas based on which the model learns. So let us perform what is called the k-means clustering algorithm. I am going to do this on the 4-band list 3 data for Dehradun. Again, I am requesting that you should all download data for your area from this ISRO's Bhuvan geoportal and try to do it yourself for your own area. You could perform it on 2 date imagery, let's say 2008 and 2018, and see what changes has occurred in 10 years and even try to publish your findings. So how do we do it? We first will do a k-means clustering. This is available in Saga. You go to Saga, image 3, and within classification, you will see k-means clustering for raster. Double click on it. You select the rasters. I say I want all the 4 and set the number of clusters to 5. I want output to be 5 classes. Ideally, you should take more number of classes, something like 20, and then try to combine them. So, how unsupervised classification works is the data gets clustered based on its pixel values. So you should create more number of clusters and then recombine them, which belong to the same class. But in short of time, I am just using 5 clusters. Iterations, let's keep at 20. The more number the iterations, more time it takes to classify. And let's keep the rest of the options just as it is and click on run. It may take a few minutes. So the output, what will be the output? It will be a land cover map which will have 5 classes. Uh, how are they created? By simply using a k-means clustering of the pixel values in the 4 bands. If you have Landsat data or Sentinel data, you can also have more number of bands that will give you even better results. Okay, my algorithm has completed and it has given me an output. The output name is clusters. It has values from 1 to 5. Let's go to layer styling and pseudo color, and I say I want unique values based on. So you see the 5 classes 1, 2, 3, 4, and 5 have been classified. The colors are not appropriate. You can double click on them and change. So I think this is urban areas. So I want to change this color to something like red. Yeah. Then these are forest areas. So this should be in dark green. Something like this. Your purple ones are also vegetation, so let's take a lighter green, but yeah, they are also, and so on. So although this is not perfect, the output is not perfect, but you could improve, as I said, by taking more number of clusters and then recombining based on your understanding of the area, and or you could create some sample data and try running some supervised classification. Okay, so this brings us to the end of this session. Again, the handout, the step-by-step instructions on how to do it is available on this link, and you can download the data for your own city from ISRO's Bhuvan Geo portal. And practice tomorrow's session is only on practicing this exercise on your own data in QGIS. So download QGIS, install and practice this tomorrow. Thank you very much.